Okay, so I wanted to go over hormone pathways for a minute, okay? And we've only really talked about one major hormone pathway. We were talking about blood sugar regulation last time and how insulin and glucagon work together to regulate blood sugar. So that's one type of hormone pathway, right? So regulation of sugar regulation. Right? Blood sugar regulation is unusual because I have talked to you about negative feedback before, but blood sugar regulation is one of the weirder ones because it is a negative feedback example, but it's not quite as linear and simple to understand as some of the other types of hormones that you would encounter. It's unusual because hold on a second here. Because it only involves one gland, one endocrine gland. And what is that gland? Yes, I know you know it, the pancreas. Right? It's unusual because it's just that's the one, get it all done and with one gland regulation of blood sugar. Not only does the pancreas secrete both hormones that either send the blood sugar up or down, the pancreas also has a built-in glucometer that can test your blood for you. Just like if you've ever seen a diabetic person prick their finger and see what their blood sugar is, your pancreas does that for you constantly. It's constantly measuring to see whether your blood sugar is high or low. And then based on that, it either secretes insulin or it secretes glucagon. So what that looks like in terms of, let me just draw you what that looks like. Just very, very simple here. So blood sugar regulation is you have, probably not going to draw it correctly, but let's say this is the pancreas, right? And the pancreas, if the blood sugar gets too high, right? If the blood sugar gets too high, don't have my writing tablet again. Blood glucose too high, right? Okay, you can read that okay. If it gets too high, that pancreas secretes insulin, which is a hormone, a protein hormone that we learned about, that triggers your body cells to either store the glucose or take it in and get it out of the bloodstream, right? And that takes the glucose back to set point, right? Or back to what the pancreas, back to set point, or the correct, best level for glucose to be. Right, so being a diabetic, I can tell you that that's somewhere between 80 deciliters of glucose per 80 milligrams of glucose per deciliter versus around 120, 130. That's the sweet spot there, right? Okay, that sends it back. And this is the pancreas, which is an organ located under your stomach, right? So it has a meter reader in it, right? It contains a glucometer in it that measures constantly. If the blood sugar gets too high, it secretes insulin to bring it back. Okay. If the blood sugar goes too low, right? If it goes too low, right, over on the other side, if it goes below the set point, it will secrete glucagon, the antagonistic hormone to insulin. Glucagon, which is another protein hormone. that will then send the glucose back to the set point. Back to set point. Somewhere between 80 and 120, right? That ideal sugar level. And that turns out to be really important for us because if glucose gets too low, you get the shakes and the sweats because you don't have enough sugar to run your brain, to run your important body cells, and that can get really dangerous really fast. You don't want to get too low. You also don't want it to get too high because if there's too much sugar in your blood, it turns into this crystalline sludge that can damage your organs, that can increase your levels of infections. If you have skin abrasions, especially on your feet, can increase the all kinds of damage to your eye tissues and things like that. So there's a sort of a double feedback loop here. This is a negative feedback loop example, but it's kind of a unique one because you only have one organ controlling both of these hormones and both of these situations. Okay? So that's the example we've already done. Now let's talk about testosterone. Testosterone is about the regulation of sperm production and muscle tissue mass, amongst other things, in human male. So this is also a negative feedback loop, but instead of just involving one gland, like the blood sugar hormones do, the pancreas is a one-stop shop for blood glucose regulation. With testosterone production, you're going much more the classic route that most hormones start with. So we start with, type this, we start with the hypothalamus. And the hypothalamus turns out to be the organ with a meter reader in it. In fact, the hypothalamus measures all kinds of things that are important to your homeostasis. Hypothalamus measures your body's temperature and will help you do things to help maintain your temperature. It measures how much water is in your body fluid. So if you get too dehydrated, it'll do something to fix that. Or if you get overly hydrated, it'll do something to fix that. And it also helps you regulate secondary sex characteristics, production of eggs in women, production of sperm in men. So constantly measuring and then stimulating the organs to follow in sort of a cascade effect that goes down. So first of all, hypothalamus is a master meter measurer. That measures many homeostatic variables. Okay. And if it finds something out of whack, it signals the gland you've probably heard of, the pituitary gland. Pituitary gland. Okay. Signals the pituitary gland, which in turn, in terms of this particular pathway, the hypothalamus in this particular pathway is secreting a hormone called gonadotropin releasing hormone. The pituitary gland, in turn, releases two hormones once it's stimulated by that hormone from the hypothalamus. It secretes something called FSH, follicle stimulating hormone, and LH, those two hormones. They both go, in a male, they go to another gland. Remember, these are all glands here. Hypothalamus is a gland that's up in your brain. Pituitary gland is a smaller gland just under the hypothalamus, hanging down beneath your brain. And then this last one here is the testes, which is also an endocrine gland, right? And it's the testes that secrete, well, it's the testes that are affected by FSH. So FSH and LH contribute to those effects and cause the testes to secrete testosterone. So if they're stimulated by LH and FSH, they're going to secrete testosterone, right? And that is going to go and do a couple of things, but mainly we'll just concentrate on a couple of things here. It's going to stimulate sperm production within the testis itself, and it's also going to affect other skeletal muscle. It also affects skeletal muscles and can increase muscle mass in the male body, in the human male body. Okay. All right. So right now there's nothing feeding back. Everything's just going. Hypothalamus stimulates the pituitary gland. It in turn stimulates the testes, and then that causes testosterone to be made, which goes and activates skeletal muscle production and sperm production. All right. You've turned this system on, you've turned the testosterone faucet on, you have got to always have a way to be able to turn it off. So many negative feedback pathways, and this is a classic one. What happens is the last thing in the row, the last product that's being produced, the testosterone, will feed back. It will feed back on the hypothalamus and on the pituitary gland, and it will turn those things off. I'll make it red to indicate to you that it will halt the production of the hormones coming from those two glands. That's classic negative feedback. Negative feedback. Final product goes back to turn off the original signals, thus regulating the system, right? Preventing the testosterone to build up too much, because you want to have a set point. A set point is the ideal amount of concentration of something. The hypothalamus is able to measure that set point, is able to say, there's enough testosterone, we turn this off. The pituitary gland also can be stopped, although it doesn't have the measuring apparatus. It can also be stopped by, okay, we got a lot of testosterone, we don't need any more FSH and LH, we're going to turn it off. Okay, so that's a classic negative feedback loop. And that's the foundation of what we're going to look at today. So I'm just going to turn this